Hello, in this in-class activity, we're going to do some simple calculations. At the end of the calculations, we're going to summarize important conclusions. Now, we have a population which has only 4 elements, 1, 2, 3, 4. This is a very small population. Okay. 1a, calculate the mean, variance, and the standard deviation. A reminder, since this is a population, when you calculate the population variance and the standard deviation, you should use the population formula. Okay. Now this is a formula for population mean. Please note that here I use a mu to represent the mean because this is a population. We calculate the mean for the population, so we use Greek letter to represent the population parameters. So 1 plus 2 plus 3 plus 4 divided by 4, 2.5. This is the population mean. Then we calculate the population variance. Again, we use sigma squared to represent the population variance. And at the bottom is no longer n minus 1 anymore. It is n. So it's a population formula for variance. Now each element minus the mean squared. So each deviation is squared and sum up over all cases divided by the total number of cases. That will give you the population variance, which is 1.25. Now population standard deviation is simply the square root of population variance. So you use 1.25, find the square root, you obtain 1.12, which is population standard deviation. We have done this. Done similar calculations before for the sample. Now this should be a very straightforward calculation for all the students. 1b, take all possible samples of size 2 by sampling with replacement. Now let me explain this concept a little bit. Take a sample of size 2 means that you take two numbers, and two numbers constitute a sample. But here, sampling with replacement, after you take the first number, you record what you get, then you place the number back into the pool and take the second number and see what you get in the second drawing. And after 2 rounds of drawing, you obtain 2 numbers. These 2 numbers form one sample. Okay, and take all possible samples. That means you keep taking samples of size 2 until you exhaust all possible combinations. Okay, so if we have 4 numbers in the pool, and if you take all possible samples of size 2, eventually you exhaust all the possible combinations of 2 numbers, as we can see here on this table. 1, 1, 1, 2, 1, 3, 1, 4, 4 combinations, and 2, 1, 2, 2, 2, 3, 2, 4, another combination. Here 1, 2 and 2 1s are 2 different combinations because 2 numbers come in different order. Okay, so for the from the a pool of 4 numbers, you take all possible samples of 2 numbers, and the total possibilities is that you can obtain 16 possible combinations, and that is what we have here. So you have all 16 possible samples of size 2. Sample size refer to in one sample how many numbers are there. If there are 2 numbers, we said that this sample size is 2. Okay. So for these are all the possible samples of size 2. Now, what this question asks us to do is to calculate the mean for each of the samples. So we calculate sample mean for each sample. Okay. And this is not too hard. Okay. And let's see how do we calculate the sample mean. Okay. For the first sample, 1, obviously sample mean is just 1, right? For the second sample, 1 and 2, and put the 1 and 2 together is 3, divided by 2, you have 1.5, okay? And the next one is 1 plus 3. 1 plus 3 is 4, divided by 2 is 2. So sample mean is 2. So you do the same for all samples. You calculate sample mean for each sample of size 2. And I did this myself, and now I have all the samples and sample means in this table. So now I calculated all sample means of size 2. Okay, so you can try to do this at home yourself. I just show you how to do it. Okay, we don't have to show for every single number. Okay. Now after you obtain all the sample means of size 2, we'll move on to 1C. Tabulate frequency distribution of the population 1, 2, 3, 4, and also tabulate frequency distribution of the 16 sample means we have just calculated. Okay. Now for this first table, we need to tabulate population frequency distribution. Now in this table, you can really see that we have the 4 numbers in the population, 1, 2, 3, 4. The question is that what is the frequency for each of the number? In other words, how many times 1 occurred in the population? How many times the 2 occur in the population, so on and so forth. Okay, and this question is not hard to answer. We know that we said that the population is simply 1, 2, 3, 4. Therefore, we know within 1, 2, 3, 4, how many times 1 occurred? 1 occurred 1 time. How many times 2 occurred? 2 occurred 1 time. And how many times 3 occurred? 1 time. And 4 also occur only 1 time. So this is the population frequency distribution. We express this in the form of a table. Okay, so tabulation. Okay. Similarly, the question asks us to tabulate the sample mean frequency distribution. Now, I put all these 16 sample means here. Let's see, also within this table, we put in each of the values that have occurred in sample mean. Sample mean, okay, we have a sample mean 1, sample mean 1.5, sample mean 2, sample mean 2.5 until we have a sample mean 4. Now let's see that within these 16 sample means, 1 occurred how many times, and 1.2, 1.5 occurred how many times, so on, so forth. Okay. Now let's see, 1 occurred, how many sample means with a value of 1 occurred 1 time. Sample mean 1.5 occurred 1, 2, twice. Sample mean 2, 1 time, 2, 3, 3 times. Sample mean 2 occurred 3 times. How about 2.5? 1, 2, 3, 4, 4 times. 2.5 occurred 4 times. How about sample mean 3? How many 3? 1, 2, 3. 3 occur 3 times. Okay. Sample mean 3.5. 1, twice, and sample mean 4 occur once. So this table shows the frequency distribution for sample means. Okay. So then we move on to 1D. Draw a bar chart of the frequency distribution of the population and a bar chart of the frequency distribution of the 16 sample means. So previously we have learned how to draw a bar chart frequency for frequency distribution, so we don't have to demonstrate how to do it anymore. You can draw this bar chart in Excel spreadsheet. You can also draw this bar chart manually. Either way, okay. So you have to do this in assignment. Okay. I've done this in Excel, and this is what I get. The population distribution, and for each number, each value occurred only once. Okay, that's why in this frequency bar you can see they all correspond to 1. Okay, so we call this a uniform distribution, a flat throughout. Okay. Also draw a bar chart for the sample mean frequency distribution. Now we see that 1 occurred once, 1.5 occurred twice, and 2 occurred 3 times, 2.5 occurred 4 times, and that is the frequency distribution for sample means. Okay. So this bar chart really visually express the pattern or shape of distribution. Okay. This obviously sample mean distribution is a symmetrical distribution. It's very different from population distribution. Population distribution is uniform distribution, flat throughout, same value throughout. But for sample mean distribution is a symmetrical distribution. Now, when you treat the 16 sample means obtained in question 1b as a population, let's say we have a population that has 16 elements, okay, and these 16 elements are these 16 sample means. Okay. Calculate the mean, variance, and standard deviation of these 16 sample means. That is, we treat these 16 numbers as a population. This is to say that when you calculate the variance and standard deviations, you should use the population formula. Okay, that is what trying to remind you. Now, all these values have specific names. The means of the sample means is called the means of the sample means. The variance of these 16 sample means is called the variance of the sample means. The standard deviations of these 16 sample means is called the standard error. The standard error. Okay, so we are introducing some terminology here. Let me just make sure that you know what we are trying to do. In this, we know that we have these 16 numbers: 1, 1.5, 2, 2.5, 1.5, 2, 2.5, 3. These 16 numbers are 16 sample means. Now we want to calculate the mean of these 16 numbers and calculate the variance of these 16 numbers and the standard deviations, the standard deviation of these 16 numbers, of these 16 sample means. The standard deviation of these 16 sample means has a special name. It's called the standard error. So just to try to make sure that you know what we are trying to do here. Okay. Now, first let's calculate the mean of the sample means. And that's not too hard. We just put these 16 sample means together, divided by 16. That is what we do. 1 is the sample mean, right? 1 occurs only once, so it's right there. 1.5 is also a sample mean. but 1.5 occurred 2 times, so it's 1.5 times 2. 2 is also a sample mean, and 2 occurred 3 times, so it's 2 times 3. 2.5 is also a sample mean, which occurred 4 times, so 2.5 times 4. 3, sample mean 3 occurred 3 times, so 3 times 3. Sample mean 3.5 occurred twice, so times 2. Sample mean 4 occurred only once. Okay. We put all the sample means together, find the sum, divided by 16. That'll give us the means of sample means. And if you complete your calculation, you should get the number 2.5. Now, variance of the sample means. Variance of sample means. We have the means of the sample means. We have the means of the 16 sample means. How do we calculate the variance? And from what we learned in the past, variance of a variable, now we treat the 16 sample means as 16 values in a variable. Okay. For each value, we minus the mean and find the square. And we do all of them for all the 16 sample means. And we sum up all those squared deviations, and then divided by the total number of sample mean, 16. So that's how we obtain variance in the past. And specifically, for the first value, sample mean 1 minus the mean of sample mean 2.5 squared. And another sample mean 1.5 minus the mean of sample mean squared. Since sample mean 1.5 occur twice, the whole thing had to be multiplied by 2. We do the same for all the sample means. Sample mean 2, sample mean 2.5, sample mean 3, sample mean 3.5, and sample mean 4. Every time we find a particular sample mean, we subtract the mean from the sample mean. Also square it, then eventually multiplied by the frequency, how many times this particular sample mean occurred. For example, sample mean 3 occurred 3 times, so when we use sample mean 3 minus the mean of sample mean 2.5 and squared, this had to be multiplied by 3. You complete this calculation, you can do this at home, and you should get a number very close to 0.625, and this is variance of the sample means. And the standard deviation of the sample means, or alternatively, we can call it standard error of the sample mean, which is same thing as the standard deviation of the sample means. We know the standard error or standard deviation is simply the square root of variance. So after you obtain the variance 0.625, you just find the square root of it, and that should give you a value 0.79. Okay. Since variance now is smaller than 1, the square root of it is larger than itself. Okay. So standard error now is 0.79. Okay. Again, you can verify this result at home, and you need to have some patience when you do the calculation. Now it's come to a very important part. What is the numerical relationship between the mean, variance, and the standard deviation of the population? These are the results you obtained in question 1A. 1A, on the one hand, and the mean of the sample means, variance of the sample means, and the standard error obtained in question 1E on the other hand. Okay, now let's slow down to look at this relationship. between these two sets of values. No, population and sample means. Remember, we have done calculations for the population and sample means. In the calculation, we calculate the mean of the population, and which is 2.5. We also calculate the means of sample means, which is also 2.5. For the population, we calculate the variance. The variance of the population, remember what it is? 1.25. That is the population variance. And what is the variance of sample means? Remember that? 0.625. 0.625. Okay. Then also we calculate the population standard deviation, which is the square root of 1.25, 1.12. We also calculate the standard error of the sample means, which is the standard deviation of the sample means. The variance of sample means is 0.625. So we can find the square root of 0.625 to obtain 0.79. This is the standard error of the sample means. Now compare these two sets of numbers: population mean, the mean of sample means; population variance and the variance of the sample means; population standard deviation and the standard error. Let's see numerically what is the relationship there. Now it's very easy to find the relationship between the population mean and the mean of sample means, because they are identical. They are identical. So it's simple as that. So we can conclude population mean equals the mean of sample means. So it's simple as that. Now variance. Population variance is 1.25. 1.25. The variance of the sample mean is 0.625. How do you establish numerical relationship between these two values? Okay. Well, if you use the variance of the population divided by 2, you would obtain 0.625. In other words, you do this: 1.25 divided by 2, you obtain 0.25. In other words, population variance divided by the sample size. And we know in this question we take all possible sample size 2. So sample 2 here is sample size. So population variance 1.25 divided by sample size, that should give you the variance of the sample mean. So that is the relationship here. Now what about here? Population standard deviation is 1.12. How that value is related to 0.79? 0.79. Well, this relationship is this. If you use 1.12, the population standard deviation, divided by the square root of 2, square root of 2, that should give us 0.79. In other words, if you use the population standard deviation divided by the square root of sample size, that should give us the standard error. So now this is what we call the numerical relationship between the population mean, variance, and standard deviation, and sample means, variance, and standard deviation. And this is a set of very important relationships here. So in this first question, we take all possible samples from a population, and all possible samples is very small, size 2. Now let's do one more time, but this time we take all possible samples from the population, but this time we want to take all possible samples of size 3. All possible samples of size 3.